Okay, this lesson is a lesson in the grade 11 chemistry course, and it's dealing with empirical formulas and molecular formulas and percent composition. I've illustrated at the top here the learning goals for this lesson, so by the end of this video lesson, you should be able to determine the percent composition of each element in a compound based on mass. Use that percent composition and molar calculations to determine the empirical formula of a compound, and use the molar mass and empirical formula to determine the molecular formula of a compound. Now, the empirical formula of a compound is the ratio of elements based on molar ratios between each element in a compound. The molecular formula is the actual set ratio. So in the case of water, it's 2 hydrogen atoms to 1 oxygen atom. That's the molecular formula. It's the same as the empirical formula, but it's so in this case your empirical formula is equal to the molecular formula, and that's equal to H2O. Now in some cases it's possible to have a empirical formula that looks something like this, CH. Now this doesn't look possible. It appears here that our ratio carbon to hydrogen is 1 to 1, and we all know that carbon makes 4 bonds, or has the potential to make 4 bonds. However, a compound that has an empirical formula of 1 carbon to 1 hydrogen will then go around, will also have a molecular formula of C6H6, and this is benzene. And benzene looks like this. Every point that I've drawn is a carbon atom, and every second carbon atom is double bonded. And each carbon atom has 1 hydrogen, which I just draw the stick to show that there would be a hydrogen. I don't bother writing them in, but there's 1, 2, 3, 4, 5, 6 carbon, and 1, 2, 3, 4, 5, 6 hydrogen. So it's possible that your empirical formula will look different than your molecular formula. What we're going to do is quickly go through a question that takes us through determining the percent composition, using that and molar calculations to determine the empirical formula, and then using the molar mass of the compound and the empirical formula to determine the molecular formula of the compound. Okay, so here we go. We've got a hypothetical problem where a foreign substance was found in an expedition to Mars. When the substance was run through a mass spectrometer, it was found to contain 2.003 grams of carbon and 0.448 grams of hydrogen. We need to determine the empirical formula of the substance. Now what I've done here is I've broken this down into different steps, and you may want to take a second, pause the video, and write out each of the steps as I've shown you here. Okay, I'm going to take you through how to do each of the steps. Now step 1, we want to determine the percent composition of each element. So to do that, we first need to determine what the total mass of the compound is, in this using the information given. So we are told that there was just over 2 grams of carbon and just under half a gram of hydrogen. So we add the two together to get the total mass. And using that total mass, we can then determine the percentage of carbon and the percentage of hydrogen. As you can see here, we take the mass of carbon that was given, 2.003, and we divide it by the total mass, multiply it by 100 to get a percent. This is the same thing you do when your teacher gives you your test score and they say you got 42 out of 50. So you take that 42, you divide it by 50, multiply it by 100, boom, you get your percentage. And so we're doing the exact same thing. What is the percentage of carbon? Take what carbon got, divide it by the total. Alright? Take what hydrogen got, divide by the total. when I add my two percentages up, it should come to 100 or really close to it. Sometimes due to rounding, you might get 99.6%, or you might get 98.8%, something close like that. That's fine. If you're getting 135% or you're getting 52 or 87, you've probably made a mistake. Now in step 2, we want to determine the number of moles of each element. So what we do here is we make an assumption. What we assume is that the percentage is actually the mass in grams. So these percentages that we have here, instead of looking at them as percentages, we're going to pretend that that's the number of grams of each element in 100 grams of the sample. Even though, of course, our sample is 2.451, let's pretend, now that we have the percentages, that we have 100 grams. And of that 100 grams, we have 81.72 grams of carbon and 18.28 grams of hydrogen. If I know mass, what can I solve for? Well, I can solve for my moles. I can determine the moles of carbon by taking the mass, my percentage as a mass, dividing it by the molar mass of carbon, and I get 6.8 moles. I do the same thing for hydrogen, and I get 18.28. Take 18.28 grams, divide by 1.01, I get 18.28 moles. So now I know my number of moles. Now remember, an empirical formula is a ratio of elements in a compound based on the molar ratio, or the number of particles. And so we now have our number of moles that we would find in 100 grams. If we had 100 grams of the sample, we now can set up our molar ratio. So that's step 3, where we determine what our molar ratio is. So we initially set up our molar ratio, carbon to hydrogen, 6.80 to 18.28. And that's our number of moles. Our next step is to divide both parts by the lowest number. 6.80 is the smallest number between the two, so we will divide them. And by doing that, we get a new ratio. 6.8 divided by 6.8 gives me 1. 18.28 divided by 6.8 gives me 2.68. Now, I've circled this and I've drawn an arrow to it because you might sometimes get a goofy looking decimal like this. A lot of times you'll get something like a 0.5 or a 0.25 or a 0.03, and then it's easy to figure out what's going on. But in this case we get a 0.68, and I purposely picked this question because it's a little trickier. 0.68 is pretty close to 0.67 as a decimal. And if you know your decimals, you'll realize that 0.67 is the same as saying 2/3. So really, this isn't 2.68, or it could be, but we could also look at this as 2 2/3. Now, to get rid of the decimal, or the fraction, we divide a fraction by, or multiply the fraction by the denominator, in this case 3. So if I multiply this whole thing by 3, I can get rid of the decimal, and when I do, I get a ratio of 3 to 8. And so now I can determine what my molar ratio is, 3 to 8. That's the set ratio, and that becomes the foundation for my empirical formula. So my empirical formula is C3H8. Now I don't know if that's my true molecular formula, what the compound actually looks like, but I know what the empirical formula is. So now it turns out that later, through some more work, we determined the molar mass of the compound, and it was 89.34 grams per mole. If I know the molar mass and I know the empirical formula, I can determine the molecular formula of a compound. And this is broken up in a couple steps here. the first step is to find the empirical formula mass. And all I do is I look at my empirical formula and I find the molar mass of it. Even though we don't call it molar mass, we'll call it the empirical formula mass. And so 12 times 3, because there's 3 carbon atoms, 1 times 8, because there's 8 hydrogen atoms, I get 44.03 grams per mole. Next, I compare that as a ratio between my empirical formula mass and my molar mass. So I take my molar mass, which will usually be bigger, or you take the one that is bigger, but it's always going to be your molar mass, and you divide it by the empirical formula mass. And when I do this, I get 2.03. And 2.03, because the decimal is so tiny, we know that it's really 2. So what we do now is we apply this. We say, well, my molecular formula would be my empirical formula times 2. And that's what I get. I get C6H16. And there you go. That's how you get your empirical formula. So now what I've got is a couple questions that I'd like you to take a look at. And just take a look at the questions here and pause the video, write the questions out. I've got 3 here, and I'll throw up 3 more in a second. So here's another 3, and again, take your time, pause it and write out these questions, because next I'm going to throw up the solutions so that you can compare your answers and see if you got the correct solution. Okay, so these are the solutions to part 1. Notice that we start with percent composition questions, pretty straightforward, and then we start to move on to the empirical formula. I've written some notes here so that you can see how I tackled the question. And I'll move on to the next 3 solutions. And here are the solutions for the next 3. So after completing these questions, if you're successful in completing the questions and getting them done correct, you can check off the learning goals for this activity. You'll be able to determine the percent composition of each element in a compound based on mass. Use that percent composition and molar calculations to determine the empirical formula of a compound, and use the molar mass and empirical formula to determine the molecular formula of a compound.